Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Find the duplicate number. So basically we have an array of numbers that contains n+1 integers, and each integer is guaranteed to be in the range from 1 to n inclusive. We have only a single repeated number, and what we want to do is return that repeated number. And the other constraint they are asking us here is that we must solve it without modifying the array, and we must also use extra constant space. So basically, if a problem on Leetcode tells you this, that means if you don't have this constraint, the problem is a lot easier. And that's actually true, because if we are allowed to modify the array, well, that is super easy. We can just sort and compare elements next to each other, right? So for example, we can just sort like this and just compare if any consecutive elements are equal, because we sorted consecutive elements will be equal, then sorry, let me just do this. Then we'll be able to find the element quite easily in overlap and time from sorting. So that's without modifying the array. The other way to actually modify the array is basically to also just go through the array, and each number you could just mark it as negative like this. And then next time, if you encounter any element that is negative, you know that that's the repeated element, because that means that we already found it, and we already found it, and we already marked it as a negative. So in this case, you could just return the element. So this also would work, but it's modifying the array, so we should not do it. Sorry about this. We need to just do like this, okay? So we don't need to sort, we just mark it as negative, and if we find any element that is negative, we return the array. And here we can just return +1. So we need to do that, right? Anyway, this should work. We will not debug it because it's not what the problem is looking for. But the other way to do this is also to just get the sum for the array, get the sum for the set, because this would be only unique element, and then take the difference. So what would be the left element would be just the actual element that is repeated. We can just divide by the difference, but this will always be 1. So we can also do that. But that's also like using extra space with the set, so we do not want to use it. The other way to do this is just to have a counter for the number of occurrences of the element. And the first time you find one that is bigger than 1, then that means it's the repeated number. But again, this one is of an extra space, so we do not want to use it. So how do we do something that is of n time without modifying the array and without using extra space? So that's where the problem gets slightly complicated. So let's see how we can tackle that. Okay, so let's see how we can do this. Let's say with the couple of things first to just keep in mind is that we have only one repeated element, so only a single one. So this makes it easier, because as soon as we find any repeated element, we can stop. And then the other thing we can think about is just another concept is we can have the indices map to the value. What do I mean by that? Because, and let's keep that, and I'll explain that in a second. But the other thing is that the problem says that the elements are in the range 1 to n. So the elements of the array are in this range. Now, just because it's an array, the indices, this means basically that the indices also are between 0 and n-1. Okay, so if we take the first array where we have 1, 3, 4, 2, 2. So if you take this array, where are the indices? 0, 1, 2, 3, 4. So the elements are 1 to 4. The indices are 0 to the indices are 0 to 4 as well. Yeah. So here it should be probably be n, because the element there will be a duplication, right? There will be a repeated element. or even if it's to n minus 1, it's still fine. Okay, and so what I'm saying here about the indices mapping to values, basically 0 maps to 1, 1 maps to 3, 2 maps to 4, 3 maps to 2, 4 maps to 2. And the main idea here is that if you present this as a linked list, you will find a cycle, okay? Which is a pretty unintuitive thing to think about, is that you convert the array to a linked list to solve it, usually the reverse. So that's where it's quite counterintuitive. But this is the main idea, is that convert array to linked list. You can do this implicitly, by the way, without actually doing it, converting it. When there is a cycle, it would be a cycle. There would be a cycle. So there would be a cycle involving the repeated element. Why is that? Let's take a couple of examples and see why. So if you do here 0 to 1, the indices basically to the values 1 to 3, 3 to 2, this one here, 3 to 2, 2 maps to 4. Okay, so 2 maps to 4, and now we have 4, right, maps to 2. And so 4 maps to 2. And there you go, we have our cycle here. This is the cycle, and the cycle involves the repeated element. And this is the hypothesis that will solve the problem based off of. But this is the first example. Let's see another example just to consolidate that this is the case. So if you have... Now, why is that the case first? Just why? Well, because if the element is repeated, you will find it as a mapping from one index and then as a mapping from another index. And so you will end up coming back to it. And that's what a cycle is. A cycle basically is an element that you found before, and then you come back to it. So that's why there would be a cycle involving the repeated element. So if we take the second number, which is 3, 1, 3, 4, 2. So clearly the repeated element is 3, and our hypothesis said there will be a repeated element involving 3. So let's see how that will look like. Okay, so let's see. So for this example, well, the indices are 0, 1, 2, 3, 4. And so from 0, that would point to 3. And then 3 will point to 1. 3, actually, we need to go to 3. So 3 here points to 4. And so 3 points to 4. And then if you look at 4, 4 points to 2. And then if you look at 2, 2 points to 3. And there you go, we have our cycle again at 3. Okay, so intuitively it makes sense, because if an element is repeated, that means multiple indices will point to it. Okay, and so at some point we'll end up finding it at the first time, adding it to our linked list, and then finding another index that points to it and putting the link back to that number, and that way we have a cycle. Okay, and so now that we established this, now what we need to do in the solution basically is, one, implicitly have a linked list basically with index to value mapping that we just did here. Now the second thing is find the cycle point. By that I mean the element where we map, where the pointer goes back to the same value. That's the repeated element, right? The element that where the pointer goes back to, that's the repeated element. And so we just need to find that cycle point. I'm just going to call it cycle point, and that's the repeated element that we want to return. Okay, so with these two we should find a solution. And so how do we find the cycle point? This one is easy. We can just do it implicitly, the first one. But how do we do this one? Well, this one, there is a cycle detection algorithm that we can use here, which is called slow and fast pointer. It's sometimes also called hare and tortoise and the hare algorithm, right? Basically, you have a slow and a fast pointer, okay? And in your linked list, let's say like this, maybe there is a cycle like this, maybe there are more elements here. You have a fast and slow pointer, so you have a slow and fast pointer, let's call them F and S. And the slow pointer moves one node at a time, but the fast pointer moves two at a time. And the idea is that at some point they will meet at the cycle. They will meet somewhere in the cycle because basically because of the cycle that will make the fast pointer go around one time, and then the slow pointer will be one or multiple times, and then the slow pointer will be able to catch it at some node, not necessarily this one, but at some node. Okay, so that's what we will do. And then once we do that, once we find that there is a cycle, so first we find the cycle using our indexing here. We do the same thing basically. We just have start from the index 0, go to 3, go to index 3, go to 4, go to index 4, go to 2, go to index 2, go to 3, right? We'll do the same thing until we find that they become equal, which we will find at some point, because the slow moves one at a time, fast move two at a time. And then when we find that, now we need to find the cycle point. Now, how do we do the cycle point? Well, we can just we can just pick the position where we find that there is a cycle, and from there just keep going until the two pointers, let's call them slow and maybe another pointer, until they are equal. Okay, that means that's our cycle point. You may ask why. So let's say we have slow here, and we have slow somewhere, it doesn't matter where, and we have pointer here to 0. We'll just keep advancing it one by one until they meet. When they meet, that means we came back to some node that we went through again, because they both move at the same speed. And so at that point, that's the cycle point. Okay? So that's the overall idea. And as you can see here, even the linked list, we will not construct an actual linked list. We will do it implicitly. That way, it's still of in time. It's still of one space as well. And of in time because we just go through the array. Okay, so that's the idea. Now let's code it up. Okay, so let's code up the solution we just talked about. So we need a slow and a fast pointer. Each of them initially point to the beginning of the array. And then we will keep going until they are equal. So that means we found a cycle. So this means we found a cycle. At that point, we just break. But what would we do? We said slow moves once. And by move in our linked list is basically just you go from the index to the number, and from the number to that as an index. So how do you do that? Well, we just say slow is equal index to the number, so it's going to be equal to the number of slow. And this number becomes the next index we go to. That's exactly what we did in the drawing. And fast is the same way, except it moves twice, which means first we do this one once, and then we do it again. Okay, and that's pretty much it. Once they are equal, we find a cycle. Now the next step is to find the cycle point. How do we do that? So to find the cycle point, what we can do is we just start with another pointer. Let's call it pointer, and let's call it start from equal to 0. And we can use either fast or slow. It doesn't really matter. Let's say we use just the fast pointer. So pointer 1, let's call it. Pointer 2, let's have it at fast. And while both pointers are different, we keep going. So while both are different, we keep going. So we do pointer 1. And same thing, we keep moving at the same speed. And when they meet, we stop, and our answer is just the value at pointer. Because where they meet, that's the cycle point. Except here, this is nums. And looks good, let's submit. it passes. Now, in terms of time complexity, this will find a cycle at after traversing the entire array, because we'll find the repeated number. And so this is O of n time, and this is also O of n time, because they will meet at the repeated number. And since the repeated number is in the array, this means that it will be just O of n time at most. So all of this is O of n time. Now, in terms of space, this is just constant variables, so it's O of 1 space. So we did have a solution that that respects the constraint we have here. Okay, so that's pretty much it, I think, for this problem for now. Thanks for watching, and see you on the next one. Bye.